Hi, everyone, and welcome and thank you for joining us for our very first virtual AstroTours. My name is Simran Nerval, and I'm a PhD student here at the University of Toronto studying astrophysics. I would like to begin today's event with a land acknowledgement. If I can get the screen to change. Okay, perfect. So I am tuning in from Toronto, which is situated on the traditional land of the Huron-Wendat, the Seneca, and most recently the Masagas of Credit River. The territory was subject to the dish with one spoon, one palm belt covenant, an agreement between the Iroquois Confederacy and the Confederacy of the Ojibwe and allied nations to peacefully share and care for the resources around the Great Lakes. Today, this meeting place is still home to many Indigenous people from across Turtle Island, and I am grateful to have the opportunity to work on this land. Acknowledging the traditional territory on which we live and work is a small but important step that reminds us to learn more about the Indigenous peoples in this region, to consider the history and ongoing colonialism on this land, and reflect on how each of us can contribute to reconciliation. We're lucky enough today to have people tuning in from across the country. You can visit native-land and whos.land to learn more about the land that you're on and who it belongs to. So if this is your first time attending AstroTours, we run our tours generally on the first Thursday of most months. After the talk, we will be heading over to a virtual meeting platform called Ovis for a variety of activities and demonstrations, ranging from virtual telescope tours to showing you how you can use Zooniverse to participate in real science. AstroTours is organized and run by graduate students in the Department of Astronomy and Astrophysics at the University of Toronto, and is supported by volunteers who are undergraduate and graduate students studying physics and astronomy. We run AstroTours to share our passion, and we really value your feedback so then we can make the event, as best as possible for you. So after the event, please go to bit.ly/AstroTours to give us your feedback. And throughout our talk tonight, please put your questions for Dr. Alcorn in the YouTube comments. Before we get to tonight's event, I'll just highlight a couple upcoming events. Our next AstroTours will be on Thursday, January 13th at 8 p.m. EST. It'll also be virtual, and it'll be by AJ Gill talking about observing galaxy clusters. A couple of events that will be happening by other organizations includes virtual Astro Trivia Night on Tuesday, January 11th at 7 p.m. EST. For more information, please visit the Dunlap Institute Facebook page. And also, there's a variety of events happening this month by the Royal Astronomical Society of Canada. You can visit their website for more information. But now on to tonight's event. Our speaker for tonight is Dr. Leo Alcorn. She is a postdoctoral fellow at the David A. Dunlap Department of Astronomy and Astrophysics and received her PhD in astronomy in 2019 from Texas A&M University. Her research focuses on the properties of galaxies and galaxy clusters and how dense environments affect galaxy evolution. In her free time, she screams into the abyss to gain forbidden knowledge beyond the understanding of her fragile human mind, and is a beginning ballet and modern dancer. A fun fact about her is that she's published two short astronomy-themed horror pieces and the Texas punk rock zine 979 Represent. And I think this is a great segue into tonight's talk on the Lovecraftian universe, or how she learned to stop worrying and love the cosmos. And I'll pass it off to you, Leo.
Hello, everybody. Thank you so much for inviting me. I'm so excited to be here talking to everybody about a subject that is so close to my heart as the combination of horror and astronomy. I am just so thrilled people are interested in this subject, since the work of Lovecraft and other kinds of cosmic horror have been present throughout my whole astronomical career, giving me a somewhat literary framework for my studies and research. So today I'm going to talk to you about my two favorite subjects, astronomy, the fear of the unknown, or horror. The universe itself, reality, how reality works, these can be overwhelming subjects. And I found that my feelings and experiences around it were very well reflected by this literary genre, which combines both horror and science fiction and discuss the phenomena that I was studying as I was studying them. And I think it really changed me, both as a scientist and a person. And I wanted to tell you both about the phenomenon and how it was interpreted through horror and why this is important to me. So to begin, I do want to warn everybody about some of the content of these books. Before going much further, there's an elephant in the room regarding this author and the literary genre he spawned. The creator of Lovecraftian or cosmic horror was a very racist man. I found this out in reading this really fun story called Rats in the Walls, which is super scary and awesome, until Lovecraft uses a completely unnecessary racial slur, and it kills the whole story. Damn it, Howie, why'd you have to ruin a perfectly good story? Some say we have to judge people by the time that they lived, but I think that's baloney, particularly in the case of Lovecraft. His work was important in the history of science fiction, popular science, and horror. But many of his works are tainted by his white Anglo-Saxon supremacist ideas. So if you read his books, be sure to read them with a very critical eye. I'm not a scholar of race or literature, but there's actually quite a renaissance of cosmic horror related to the concept of race that is happening right now. And I greatly encourage you to learn and read as much as you can about this. One person I know of who is very qualified to talk about this rather than myself is the writer and professor Victor Laval. If you want to delve into this subject, look up his work. He's written fictional works that are Lovecraftian in nature, and he gave a very interesting interview on the podcast Imaginary Worlds, where he talks about the fascinating and interesting relationship between the Black experience in America and cosmic horror, and the current media that's being made by writers and creators of color in this genre. Also, I want to mention there will be a lot of spoilers in this talk, but these stories were written in the 1920s and 30s, so I think I can give you spoilers. Also, cosmic horror kind of changed the face of horror and science fiction, so you likely already know a lot of these plot points, even if you haven't read any of Lovecraft himself. Also, sorry for cute Cthulhu. I even have a little stuffed Cthulhu. He might show up occasionally. You really shouldn't take yourself too seriously in this genre, otherwise the madness will get to you. So we'll start out by talking about science fiction as a whole. The whole of science fiction as we know it starts with Mary Shelley, who wrote the first true science fiction novel after getting into a friendly competition with Lord Byron to write the best ghost story during a very miserably rainy summer. She and her friends were stuck inside during their vacation and started discussing the nature of life, and the topic turned to a subject called galvanism. This is the study of using electricity to stimulate muscle contraction and produce chemical reactions. So she was understandably pretty horrified and fascinated by this thought. And she actually recorded, she didn't sleep that night thinking about it and only saw in her head a reanimated corpse. So she wrote the story about it. And rather than a ghost story, she created a horror story that inspired a whole new genre, science fiction. Not only does she use new science as a plot element, she delves into the implications of this new science in her work Frankenstein, seen here to the right. Not only that, this tells us about herself as well as the science that she was learning about and the culture she was in. Death was a constant in her time. In fact, she had lost her first child to a stillbirth the previous year. Her mother had died shortly after she was born. She even lost her husband very, very young, although this was after Frankenstein was written. Not only do we see the influence of this new science, we see a person using this new science to make sense of her life and her losses. It even gives us a peek into her time and how this would have been seen. So science fiction continued to do this throughout time, sharing not only scientific ideas, but the societal understandings of that science. So I thought a lot about science fiction and horror fiction that I was shaped by. I think you can learn a lot of interesting things about a culture or a person from the art they produce and enjoy, particularly these very fantastical genres of art like science fiction, horror, and fantasy. I got the idea for this talk from a podcast that I listened to called The Horror Vanguard, which does analyses of horror media, particularly horror films, in a political lens. One of the hosts, a film student, says, "Films are the dreams of a civilization, and horror is its nightmares." And it made me want to look deeper into the science fiction and horror that shaped me and the folks around me and the research that we do, and even the cultures that we were brought up in. But I'm not focused on politics. I'm more interested in how scientific ideas, discoveries, paradigms are transmitted and analyzed through these fictional works. And I want to understand how that can be used eventually to better teach science and explain my own research, as well as help both myself and my colleagues think outside the box of work. Science fiction has changed a lot over the years, partially because science has changed a lot. There are some examples of earlier sci-fi and various subgenres exploring various ideas. So here they are, which gives us new ideas. However, I like to think this genre is a little bit more like mythology than prediction. The great science fiction writer Ursula Le Guin, seen in the center of this, who wrote Left Hand of Darkness in her introduction, she says, "I am not prescribing, I am describing." So we learn more about history and our current times from these genres rather than anything of a purely speculative nature, which is how I'm treating these genres when I talk about them, and why I'm interested in this subject as a matter of both self-discovery and as an analysis of the nature of science. So with that introduction, I want to start talking about the circumstances around science fiction and horror that I delved into when I began my astronomical studies. In the early 20th century, science fiction was very commonly shared in pulp magazines, which were called that because they were made from cheap wood pulp, so they were very accessible to the average person, very cheap. But because of that, it was kind of considered a trashy literary genre at the time, but so many wonderful ideas and stories and characters are presented in them, like the works of Lovecraft seen here. But also so much other contemporary media owes its origins to pulp magazines, validating my love of so-called trashy horror media, because it takes a lot of freedom, because there's a lot of freedom in working with ideas when the stakes are lower and the media is accessible to people of all socioeconomic means. There are also different kinds of pulp, like detective pulps, crime pulps, adventure pulps, romance pulps. And you even know a bunch of characters probably that were introduced in these kinds of pulps. Characters like Zorro, Buck Rogers, Tarzan, and Conan the Barbarian, they were all actually in pulp zines. Since this is where Lovecraft published most of his stories, now I'm going to move to Lovecraft himself, since we know where he published. So HP Lovecraft, or Howard Phillips Lovecraft, colloquially known as Howie by me, was born in 1890 in Rhode Island, and boy, does he love writing about New England and how creepy it gets sometimes. He was born into a previously wealthy family, but they had lost their fortune after his father died. Lovecraft was a very quiet, bookish dude who loved reading and learning just about anything. He published his first short story in a magazine at age 17, but didn't start publishing regularly until 10 years later in pulp magazines. He never made much money off of his writing and was relatively unknown in his time other than by other pulp writers. Despite his lonesome tendencies, he started up quite a bit of correspondence with many other pulp authors, some of whom he mentored, some of whom he just collaborated with. Some examples include Robert Bloch, who wrote Psycho, which was later turned into a film. Robert E. Howard, who wrote the Conan the Barbarian series, which actually shares the same universe as the Lovecraftian universe because of the heavy collaboration between the two. He also authored a lot of really trashy romance, by the way. Don't let him forget. And August Derleth, who was the person responsible for actually publishing the works of Lovecraft after his death. Speaking of his death, Lovecraft died actually very young. He was in pretty poor health and refused to see a doctor until it was far too late, and he died of intestinal cancer. Go see doctors, people. He had no heirs, and he had no interest in securing copyrights to his work, so all of his solo works are actually public domain, leading to an explosion of writers influenced by his work after they were published by August Derleth. Some writers and filmmakers today you would know who either explicitly cite Lovecraft as an influence or who are clearly building on his ideas include Stephen King, Junji Ito, Guillermo del Toro, Jordan Peele, John Carpenter, but I'm only listing my favorites here. There's a whole world of people influenced by his works. Also, since his works are free, you can actually find them very easily in written or audio form online for no cost. You can find them on YouTube, you can find them on Spotify, you can find, there's even a webpage that keeps all of his works in one place. So check them out with my content warning from the beginning of the talk in mind. So we know for a fact that Lovecraft was a science fanboy. He kept up with the scientific literature and discoveries of the day quite closely, which is why I'm giving this talk due to how much it influenced his writing. Not all of his stuff was influenced by the science of the time, but I think the most interesting stuff was. Originally, Lovecraft actually wanted to be an astronomer. Yay! As a teenager and a young adult, he kept logs of astronomical observations for fun, some of which you can see pictured here. That's his astronomical observation notebook, where he has a picture of a comet he saw. And he actually published in some amateur astronomy journals some of his observations. Just as we can see in this letter that he wrote to a friend, He didn't go into astronomy because he thought he was bad at math, and clearly he didn't care to learn. Note to anyone listening, few people start out good at math. You just have to keep trying. It sucks, but just keep trying. Eventually you'll get it. Ask for help, it's okay. Despite this setback, Lovecraft maintained a very strong interest in physics and astronomy as it was being developed in his time. So we'll talk about the very cool discoveries in science that happened during and before his life that he incorporated into his writing. At this time, physics was changing from what it used to be. This was when the two main paradigms of general relativity and quantum mechanics were being developed. So I have some pictures here of some of the prominent astronomy thought people of the time period, including Einstein, Max Planck, and the prominent physicists of the time at the 1927 Solvay conference in Brussels, where they were hammering these ideas out. Space and time themselves in general relativity became relative concepts, as an idea seen on the left, where time becomes another dimension and is merged with space. The consequence of this idea turns many things we think we understood on its head. In special and general relativity, we learn that space and time can be stretched or warped depending upon the frame of reference both the subject and the observer are at. We learn that perception is relative. See what I did there? Relativity? It also leads to a very different understanding of gravity, which helps us understand why this force acts over long distances without objects touching each other. They're warping the space-time between them. There's a demo about some current research that's being done on gravitational waves, which are a consequence of general relativity, that you can check out after the talk, and you can even contribute to some of the research because I believe it's by Zooniverse. Additionally, the physics of the very small was being explored. The very stuff that makes up matter was being understood in new ways. Quantum mechanics was being developed at this time, which turned the deterministic or step-by-step predictive universe on its head. Since quantum mechanics actually predicted a probabilistic or random universe where nothing can really be determined for certain until the measurement is actually made, which can change the system by measuring, just like Schrodinger's cat thought experiment shows us. A science that predicts the phenomena change based on how you observe them. Sounds like hogwash, right? Well, it's not. We still use it today. These scientific paradigms of quantum mechanics and general relativity are still being explored today, and it's the scientific paradigm we have, and have shown a lot of promise and have very successful predictions. So in this new age of science, what we thought we knew was utterly dashed, and the whole terrifying universe and its consequences were left to be explored, not just by scientists, but by everyone. For example, new science had resulted in new technology, which resulted in new weapons, which were put to use in the horrifying meat grinder of a war, World War I, which literally traumatized the whole world. Science in this way proved to be a double-edged sword, dangerous but fascinating. That we have this useful knowledge that can be used for both wonderful, medical, fantastical, curiosity inducing things, but it can also be used for horrible things like war. This is clearly something we're still dealing with. So anyway, here we can see Lovecraft's reaction to this. I love this quote from the beginning of Call of Cthulhu. I have the quote written on the right, but I'm about to play a very fantastic retelling of it by a Lovecraft scholar and impersonator. Hopefully you can hear.
The most merciful thing in the world, I think, is the inability of the human mind to correlate all its contents. We live on a placid island of ignorance in the midst of black seas of infinity, and it was not meant that we should voyage far. The sciences, each straining in its own direction, have hitherto harmed us little. But someday the piecing together of dissociated knowledge will open up such terrifying vistas of reality and of our frightful position therein, that we shall go mad from the revelation or flee from the deadly light into the peace and safety of a new dark age.
So here we can see that these new ideas are honestly kind of disorienting. Nobody knew what would happen as we learned more, considering just how weird the universe got by the development of general relativity and quantum mechanics. And Lovecraft, for one, seems to think humans can't handle that. I disagree, but that's for later in the talk. So what did Lovecraft bring to this new genre? Here, I honestly copy pasted the definitions of this genre, which is Lovecraftian or cosmic horror, that I thought were the best descriptions of what defines his work. Lovecraft actually wrote about a scientific rather than a supernatural universe. In this way, it's science fiction. There's this idea that humans are only equipped to understand a small part of the universe because we are just small. We have simple brains. Seeing how reality works is just beyond us, so it would destroy us. One could say that it's not the horrifying gods or monsters like, Cthulhu, my friend here, Nyarlathotep or Shoggoths that are the source of horror in these stories. Honestly, some of the monsters in his stories can be a little disappointing at times. Ooh, scary monster, I'm insane. But instead, the universe itself is a source of horror. The universe is the monster. So the universe becomes a source of horror. I am also kind of amused because in astronomy, we actually do assume a lot of these things already. We assume that we're just a small part of the universe and we're not in a special part of the universe. In fact, there is no special part of the universe. So here Lovecraft has taken the base assumptions in astronomy and turned it into a narrative point, which just tickles me. I love it. So where does humanity fit in? And what are these characters and narrative structures like? Again, we see the idea that humans do not matter. We are insignificant. We are not special. There is no compassionate force that cares about us in these narratives. And instead, we're subject to the uncaring universe. Also, one can see why these characters in Lovecraft stories appeal so much to scientists and folks that are interested in science. Often his characters are academics or scientists. They're awkward or reclusive, like me during my grad and undergrad years. But his characters are also incredibly fragile mentally. They're unable to cope with the truths that they've set with the truth that they've set out to find. And usually by the end of the story, they're either dead or writing to you a letter from the grave, or they're writing their recollections down at a mental hospital. Now, I think this tells us more about Howie himself than humans as a whole. Hence, I'll tell you my interpretations and reactions to the truths Lovecraft writes about are quite different. It also tells us quite a bit about the reaction to the new scientific truth of the time, one of fear and uncertainty. So with that, let's get into some stories, my favorite stories of his with scientific themes. First of all, we have The Color Out of Space, which, by the way, somewhat recently, there was a movie about it that came out with Nick Cage, and Nick Cage it's his absolute A game. Go see it. Color Out of Space, they kept it fairly close to the actual story, just modernized it. It was wonderful. I loved it. Anyway, so plot summary, an asteroid hits a piece of farmland. It starts to poison everything around it. It seems to be like radiation. They're not sure if it's like a life form or if it's like a chemical phenomenon. They don't understand what it wants, what it's doing. But scientists are trying to study it using what would have been contemporary research equipment at the time. So I put a quote here that I'm not going to read out loud to you, but the scientists start trying to take a spectrum of the object and get really excited because it doesn't show any elements that humans seem to know about. So I'll talk about that in a bit. Oh yeah, and then everybody dies at the end or goes insane. Standard Lovecraft. So the color or the monster in the story behaves quite a bit like radiation, but I only briefly want to mention this as this was being developed as Lovecraft was writing, and we see the fear of what this new power can do. So radium seemed absolutely cool at the time period because it glowed. It was super awesome. Carried around or glow in your pocket. Also would give you cancer. And it could actually lead to some very cool medical applications. I mean, we use radiation for medical applications now, but a lot of the people who worked with it or who worked on the research died due to exposure from radiation. They weren't dumb. They just didn't know what it could do, and it ended up hurting them. I mean, for example, Marie Curie used to carry around a piece of radium in her pocket. Tongs, oh my God. Anyway, so again, science is that double-edged sword. But moving on to more of the physics that I do, in that quote I gave you, I was just totally tickled when I read this the first time, that when Lovecraft described how scientists of Miskatonic are trying to study the asteroid with the color that he mentioned. So he mentioned that they measured a spectrum to learn what the material was made of. So I'm going to briefly go into quantum mechanics a little bit so I can tell you about how spectra work. So on the left, we see the Bohr model of the atom. This is a hydrogen atom with one proton, one electron. So the electron and other subatomic particles exist in this model in a definite space and time. One can predict their motion and how they're acting on by examining their current state, which is where they are and what forces are acting upon them. However, in quantum mechanics, this is not the case. Instead of this predictable or deterministic universe, subatomic particles, particularly the electron, exist in a cloud of possibility. We can't know their definite location or motion, and definitely not at the same time. Yay, Heisenberg uncertainty principle. So on the right, we see instead the brighter areas are where the proton is more likely to be. We can't know for certain. So it's shown as a cloud of probability of existence in that area. So each of these different squares is a different energy level of the electron. These different energy levels are, so this has to do with how much energy is in the electron. So how many photons of certain energy levels have hit it. However, these energy levels are discrete. They're small. They're, may I say, quantized. And they're all very different for different elements. So when Lovecraft talks about scientists measuring the spectrum of this weird space rock to determine its elemental composition, this is a consequence of quantum mechanics. Different elements and molecules have different patterns of light that are released when they're heated, and the light is separated into different wavelengths using something like a prism. So here's an example of the phenomenon. On the left, you can see the setup where there's different lamps that are sent through, where the light is sent through a prism. When white light is sent through a prism, you get a rainbow or a continuous spectrum. This is how rainbows are made. Instead, like raindrops and clouds are used instead of a prism. So there is an example of this at the demos tonight. There's a demo about black body radiation you should check out if you're interested in this. But individual elements can release light at very specific, quantized, and unique wavelengths. So by looking at the pattern of light, where the light is being emitted at different wavelengths, at different energy levels, you can determine the amount of an element in there and its presence. So now that we've seen how scientists in the Colorado space use spectroscopy, I use spectroscopy nearly every day at work. My entire thesis and most of my research now is built using one of these emission lines from hydrogen, the little red one far on the right on top. That's called hydrogen alpha. We see it very, very often in space because the material in the universe that we understand that isn't dark matter is mostly made up of hydrogen. And this includes stars. Stars are mostly made up of hydrogen. In particular, it's a sign of very strong recent star formation. How? Stars are born in clouds of hydrogen gas. If the gas falls into a dense gravitational potential or well, it ignites and it forms a star. Oversimplified from the protostellar people, but I'm an extragalactic astrophysicist. Anyway, stars, like our sun, are so hot that they produce a continuous rainbow-like spectra. So you can see this on the bottom right figure. But young stars are still surrounded by their birth clouds. An example of this that you can see with some binoculars or a telescope are the Pleiades cluster or the Orion Nebula, which are both clusters of stars surrounded by glowing birth gas. So as the light from the star hits the gas around it, the gas heats and the electrons in the gas are pushed up in energy level. But electrons are like me, they're very lazy. So they emit light at very specific wavelengths depending upon which energy is being released as a unit of light, or a photon, so that they can go down to a lower energy state. From the photons, eventually we can see this light pattern, which on top, which in that particularly lovely red line is one of the most common energy transitions. Isn't hydrogen great? It can be used for so much in astronomy. So next work, since I'm going over these somewhat quickly, the Whisperer in Darkness. So plot summary. A professor at Miskatonic University, a very common setting in Lovecraft's work, receives a very weird letter from a friend of his named Ackley, who lives in the middle of nowhere with just a bunch of dogs. I don't know, sounds pretty nice. Ackley claims aliens are attacking him and his dogs, and that aliens are very much real. Eventually, but this professor ignores it because we receive weird emails all the time in academics. But Ackley has a very drastic change of mind one day and says, "Hey, you should come over. The aliens are actually very peaceful and they want to take us and they want to talk to you." So the professor visits his friend. Why? All right, sorry. This is anyway. But yeah, so he goes and talks to his friend, and his friend introduces him to some of the aliens, and the aliens want to take him to Yugoth, which is one of the planets that they're from. Yugoth is actually Pluto. and they want to transport humans to see this planet. Thing is that in order for humans to travel through space, they have to remove the human's brain and put it in a jar. It's one of the first brain in a jar stories as well. So maybe the biologists or neuroscience people should talk about this as well. But it turns out this guy doesn't want to do it. I don't know why he wouldn't. I would love to go into space, take my brain out, sure, whatever. Yeah, so it turns out the Ackley he was talking to, Ackley was already in one of those jars. That was an alien in a mask. Oh no, maybe he's insane now. Anyway, so the science behind this story is written in the same year that Pluto was discovered, in 1930. Clearly, Lovecraft had been reading the journals. It was discovered by a guy named Clyde Tombaugh at the Lowell Observatory. So here are some cool pictures that I took during my holiday to the Lowell Observatory in Flagstaff, Arizona. In 2015, during the Pluto pass-by with the New Horizons satellite, which showed us that Pluto has a heart-shaped plateau on it. It was very cute. Anyway, Clyde was a worker at the Lowell Observatory. He wasn't an astronomer, but he was very good at building telescopes. And because he was good at building telescopes, he got actually very good at observing. So he was hired by the observatory, and they sent him to take a look at trans-Neptunian things beyond the orbit of Neptune, where he was only 23, 24 years old. And he discovered Pluto and the Kuiper Belt, which is a belt of asteroids, dwarf planets, and comets at the edge of our solar system. So, of course, after this discovery, he was sent off to get his doctorate because, I mean, come on, the guy discovered Pluto. So, yeah, these images here on the left is a bust of Clyde that they put a cute shirt on. In the middle is the observatory, the telescope that he discovered Pluto on. And I didn't take this picture on the far right because I'm not very good at photography inside, but that is the actual telescope he was using. So that was very fun. I got to see it. It has a boxing glove on one end of it because people kept on hitting their head on one of the weights. Anyway, so also here are the original plates where he discovered the planet Pluto. You can see two arrows pointing out where Pluto has moved during the course of a few days. So I always get super tickled seeing this. So yeah, basically what he did, he just flipped these images back and forth using a special device to see what moved and what didn't. This is by eye, my God. Anyway, so if you're interested in Pluto, you should go to one of the demos, to a few of the demos after the talk. Zooniverse has people who need to find trans-Neptunian objects, aka Planet 9. So there's a way that there's a demo where they can show you how to do that. And there's a 3D model of the New Horizons telescope, which is the satellite that went and looked at Pluto. So that was super interesting. So not only was Pluto discovered at this time period, making the solar system much bigger, but the universe as a whole became much bigger. This is a little bit before The Whisper in Darkness was written, but I still think it's interesting. This is actually the first story where Lovecraft uses the word galaxy. Galaxies weren't really known before the work of a guy that I'm going to talk about in the next slide, Vesto Slipher and Edwin Hubble. Until this time, there was no evidence that there was anything outside the Milky Way, and people thought that things that we now know are galaxies, such as Andromeda, the Pinwheel Galaxy, they thought that they were called spiral nebula, which are much smaller and inside the Milky Way. And there was a lot of research being done on these things. They seemed a little confusing. But chronically, just criminally underknown scientist, Vesto Slipher on the left, not the galaxies, measured the spectral lines, aka the things that I showed you in the previous story. And he measured the spectral lines of several galaxies and noticed that these lines appeared to be shifted to the red from where they should be. That means that they're moving away so fast that the wavelength of the light is stretched out, making it appear redder. We call this redshift in astronomy. This also meant that these objects were actually moving far too fast to be inside of the Milky Way. It was impossible. So they determined they're outside the Milky Way. So that was cool. Additionally, what he found was that one side of the galaxy was slightly blue, was moved slightly blue compared to the rest of the galaxy. One side of the galaxy was moved slightly red. So that meant one side was moving toward us, one side was moving away. That meant these were rotating. Isn't that interesting? So as you can see, there's two pictures of I think the Pinwheel Galaxy and the Sombrero Galaxy here, showing exactly what I mean by this red and blue shift, this slight difference in rotation that can be measured. So how did he do this? He used a spectrograph. I took this picture at the Lowell Observatory. This is the spectrograph that was used to discover this. So yeah, he measured spectra of these galaxies just like in the previous story. And yeah, he saw that they were moving away way too fast and that they were rotating. Isn't hydrogen interesting? All right, last work, Dreams in the Witch House. This is one of my favorite Lovecraft stories ever. It's not a short story. It's a bit longer, but I got excited reading it for the first time because it was about a physics student, and I was a physics student then. And he had gone off to uni to study math and folklore and physics. And I thought, oh, he sounds just like me, except he dies horribly at the end. So hopefully that doesn't happen. Anyway, so while he is there, he rooms in a house that a witch had lived in the 17th century. But he's a man of science. He doesn't believe in any of this. But he takes the upper room, which is where she used to live, and he notices weird things start to happen. And in fact, she visits him. It turns out that she's not doing any sort of magic. She's just sort of an early mathematician and applied physicist. She knows how to use these equations to travel through space and time, to bend space-time. So yeah, and eventually he dies at the end. I mean, again, standard Lovecraft. So let's talk about the science in this. Lovecraft loves the term non-Euclidean geometry. It appears in so many of his stories. So I'm just going to explain a little bit about non-Euclidean geometry for you because it's actually kind of important for general relativity. Non-Euclidean geometry wasn't actually a very new thing when Lovecraft started writing. We think it was developed by Carl Gauss in the early 1800s, but he never published it. It seems to feel wrong to people like Lovecraft because Euclid in ancient Greece came up with these geometrical theorems. This was standard Euclidean geometry. Basically, he has these shapes and they're all on a flat surface. And there's, for example, a rule that triangles can only ever add up, the angles in a triangle can only ever add up to 180 degrees. Okay, so that's Euclidean geometry. That's a triangle on a flat surface. But what if you put the triangle on a curved surface? That's non-Euclidean geometry. So here's two examples of spherical and hyperbolic geometries, which are both non-Euclidean geometries. So in a spherical geometry, the triangle will always add up to more than 180 degrees, all of its angles. In a hyperbolic geometry, the triangle will always end up equaling less than 180 degrees. So it's not actually all that scary unless you're taking a GR course. Oh my God, it's so hard. So that being said, this new math made GR very possible to develop because you have to use this geometry to figure out how light travels in curved space-time. So as an example of how this is used, gravitational lensing happens because of general relativity. If something is very, very massive, it warps space-time around it. So say we have a galaxy cluster. If something is behind this galaxy cluster, say here, the mass of the galaxy cluster can warp space-time around it. So you might be seeing multiple images or warped image or even magnified images of objects around it. And actually, yes, this does exist. There's pictures. In fact, I even got a picture of it tattooed on my arm. See, there's my galaxy cluster. Here's my background lensing galaxies. Let's see what happens. Add a little mass to the system. Sorry, just a little mastrophysics for you. Anyway, this was so fascinating to me that this actually happened that I changed my major from fermentation science to astronomy when I learned that this exists. Yes, I was going to make beer for a living, and this is more interesting than beer. So I've talked to you for a bit of time about these stories and the science behind them, but I actually have a major disagreement with Lovecraft and how his characters react to these phenomena that I wanted to share with you. And this is less of a science thing than a philosophy thing. So yes, I'm disagreeing with a dead guy as well who can't defend his ideas, but he was a racist, so I don't think y'all will get too mad at me for that. So as we discussed, there's so much fear and fragility in the minds of his heroes. However, the process of science and seeing the phenomena with my own eyes changed me in ways almost as dramatic as Lovecraft's characters when they encounter these great terrifying truths. Only in science, when your reality is challenged, you're trained not to break. You're trained to explore this further. In this way, we can turn old Howie's ideas about science on their head. So I see how small I am. I see how little I understand. But rather than let that consume me, I can see it as a source of joy. In that way, I like to joke that I can relate more to his cultist and mad scientist characters. There's just so much to learn, and I may be small, but it's all I have, and I may as well use these tools that my training taught me to dig in further, because it's honestly amazing that I can measure the universe. So I want to focus on an example from my own research. When you're a professional astronomer, sometimes you can get very easily caught up in numbers, formulae, lots and lots of coding. Oh my God, the coding. But when I actually take a step back and put these numbers into something that's real in my head, I find myself in a situation very similar to what the protagonist of Cosmic Horror find. I am just a great ape who uses the brain that developed to forage and communicate with others and work together in small groups and recognize even slight danger to study something that is so huge I cannot imagine it over processes of time that take longer than human evolution has even taken. How can I be equipped for this? So here is a cluster I am studying right now. If you want to look it up, it's called Abell 2390. This galaxy cluster is located so far away that the expansion of the universe stretches out the wavelengths of the light released, so that when I measure it, it's shifted to a redder color. It's redshift. The light has taken 3 billion years to reach Earth from when it was released. Humans weren't even around when that light was released from the galaxy cluster. Dinosaurs weren't even around. It's like looking at a great old one, like looking at Cthulhu right in the eye. This cluster is made up of hundreds of galaxies, all traveling through this cluster, attracted to the gravity produced by the dark matter that holds this cluster together. And through gas that is moving so fast, it's heated until it glows in the X-ray wavelengths. As galaxies fall into this cluster, the cluster strips the gas off of them to form more of this hot gas between galaxies in the cluster, and it keeps them from forming more stars, in a way almost killing them and creating a necropolis of dead galaxies. And this space is the spatial environment, this dense environment is so different from anything we know. It's even different from the environment of our own galaxy, the Milky Way. There is so much matter that it warps space-time around it. Gravitational lensing forms, sort of like I showed you in that last story. Here's a lens, a picture of it, for example, and you can see some of these galaxies are warped out. So these numbers are so huge and there's so much here, and I'm so small, and I deign to study a phenomenon that kills galaxies. I'm just a curious ape that wants to understand the process of how galaxies have their gas removed from them and shut off star formation while in a cluster. Will I even understand the data I receive from these galaxy clusters? Now you can kind of see why Cosmic Horror is almost the best way to express this majesty. There's almost no other way to convey the majesty of them than by expressing both terror and awe. Like it's like looking Cthulhu right in the face. Think of the time spans, think of the size, and let it overwhelm you. This is real. This is what's actually out there. They called me mad for my obsession with clusters, but soon they will realize it is they who are mad. Anyway, so now you can see why I named this talk, Why I Learned to Stop Worrying and Love the Cosmos. So we're running out of time. So if you take nothing else from this talk, I want you to learn from these stories, perhaps a different way to look at things you don't understand. And I think that this is actually a more scientific way of looking at these things than Lovecraft presented. Unlike Lovecraft, look into what you don't understand, and you can find beautiful things in them. Even though you will be driven to more questions, I guess that's kind of like madness. Openness to what's there rather than the rigidity seen in Lovecraft's protagonist will allow you to truly learn about reality in the universe. Let your observations and let the science change you. That is the nature of learning and integrating what you have learned. The universe is bigger and weirder than anything we can conceive of, and I think that is a beautiful thing, because there is always more to learn. When the void or Cthulhu looks back into you, stare him right in the eye and ask more questions. Because even if you don't find all the answers, you'll find some. And with that, I'll end here. Sorry, I might have went a little over time.
Thank you, Leo, for that super interesting talk. Yeah,
I'm glad people are interested.
Also, I guess before we get to questions from the audience, and to remind the audience, put your questions in the YouTube comments and we will get to them live. That the very last image you just had, was that this Cthulhu, the same thing as your stuffed animal?
Yes, that's Cthulhu.
Oh my goodness. That's such a drastically different representation of it.
Yeah. There's some drastic reinterpretations. I think an example of the mixture of these two depictions of Lovecraft was seen in South Park. If you are interested in South Park, a nice middle ground.
Wow, that's really funny. Okay, so I guess we can get to some questions from the audience. Let's look through the chat. Okay, well, that is, so yeah, make sure to post your questions. I guess I can start off with some of mine.
Okay.
Yeah, so you were talking about spectra a lot, and you had these images that had, a continuous spectrum, and you had some of these ones that were more like had black lines missing or just lines in certain spots.
Here we go.
Yeah, so I was wondering if maybe you could just like elaborate a little bit on why some of these spectra look like are mostly black with just like these small portions of light.
Okay. So why are they mostly black? Because what's going on is quantum mechanics says that each electron can only receive specific little packets of light or photons. These photons will have very specific energies. And depending upon the configuration of the electron, shown, say, here, it can only take some wavelengths or some energies of light, and it can only release some wavelengths or some energies of light. And when that happens, say, for example, in these cases, what's going on in these lamps, these elemental lamps, is that it's just pumping this energy into the gas and bringing it up into more and higher energy levels. So what goes on is these electrons want to go back to their ground state, their lowest energy state, because again, they're very lazy like me. When they do that, they can only release certain wavelengths. They can't release a continuous spectrum. So that's why they are releasing only specific lines, only specific energies. Unless you're dealing with, say, a black body spectrum, which is a little bit different.
Yeah, thanks for the great answer. And yeah, that really helps explain why, astronomers use spectra to study a lot of things. You can figure out what's inside of them.
And I've measured things like oxygen and carbon and nitrogen in galaxies. You can see they have various patterns. So as you get into the field, there's actually little complexes that you actually learn how to recognize by eye. Like I can, from a million miles away, tell you whether I'm looking at hydrogen alpha and the nitrogen lines, or whether I'm looking at oxygen and the hydrogen beta line. Hydrogen beta is this line. So yeah, there are cool little complexes. You learn to recognize the patterns so that when something is, say, redshifted, moving very, very fast away from me, I can tell, oh, well, that's not the right position, but it's the right pattern. It's definitely the right pattern. So this thing is moving away from me really fast.
Wow, that's really cool. I guess we can go to our next question, which is, would the warping of time and space around large masses benefit space travel?
Ooh, so actually, it's not so much of a benefit, but it's something that we actually do have to utilize. So for example, in order for like satellite technology to work, I'm gonna just go to this. So in order for satellite technology to work, we actually need to pay attention to this. I don't think it's actually like gravitational lensing, but if you do not take into account relativistic effects from the warping of space-time, from Earth's gravity and from the orbit of a satellite around the Earth, you'll actually get weird time offsets. So say anybody who works with a satellite, even like satellite TV, they actually have to count time differently so that they can communicate with Earth in the right time periods because they're actually traveling. So these satellites are actually in a different frame of reference. So time is passing differently for them. In addition, this has actually been proposed as a method of time travel, where say you find something like a supermassive black hole, which warps and stretches the space-time around it to the point where when you get close to the black hole, and this was actually seen in the movie Interstellar and used as a method, as sort of a plot point, and I was kind of tickled by that. As you get close to the black hole, if you orbit around it, time will pass differently for you than everybody outside of that warping of space-time. So you'll be traveling through time faster, but not according to your frame of reference. Things will appear to go normal, but you will be traveling for longer than everyone else. So you can appear in the future. So it's kind of a weird way of time travel, but it's one of the proposed ways of time travel. And that might be like useful for some people.
Yeah, that sounds really cool. And yeah, it's also really cool that, like, you know, standard things we use every day, like our GPS when we're using Google Maps, you know, it has to use these concepts or else it would not send you to the right location.
It would not. And timing would be off.
Exactly. Okay, so now on to the next question is, what is your favorite Lovecraft short story and which is your least favorite and why?
Okay, I think my favorite Lovecraft short story of all time. Let me see. That's a tough question, actually. I like a lot of them. I would probably say The Color Out of Space. It's just fantastically creepy. And Lovecraft doesn't do anything sketch in it. But also all the science in it is pretty fun. You can tell that he was reading the scientific journals of the day because there's just whole scenes of scientists trying to study this thing just like scientists at the time would have. My favorite of his long stories is Dreams in the Witch House because I as you can probably tell from how I'm dressed, I think witches in history are just totally cool, and I would love to look like one. Also, I like physics, and I'm a physics student, and I thought that was awesome. I don't want the fate to befall me that happens to the main character, but I do want to travel through space-time. Honestly, I kind of want to be the witch in that story. As for my least favorite Lovecraft story, let's see. I actually am kind of disappointed in the Call of Cthulhu. I'm not gonna lie. I read Call of Cthulhu, and it's just a bunch of like letters within letters. It was very confusing. It's just some guy saying, "Oh, I heard a story from this dude who washed up on who we rescued from being free floating in the sea, and he told us the story about a guy he knew who might have seen Cthulhu, and then they rammed Cthulhu with a boat, and then Cthulhu went back to sleep." Very disappointing. I'm sorry. Just not a very fun story.
Wow. That's interesting.
Yeah. So Cthulhu isn't actually very scary in the books, which is why I can kind of adorable him. The Lovecraftian god that I'm a little bit more scared of is called Shub-Niggurath, because like she's also called the Black Goat of the Woods with 1,000 young, and she's the one who actually works with the aliens from Yugoth or Pluto, and she has like followers who try to find people, and she has like these weird hybrid children with aliens and humans that will eat you. It's kind of terrifying. She's actually more terrifying, but she doesn't get enough. I don't know. I like to joke. Maybe why is she not getting enough attention is because she's a woman.
Yeah, that wouldn't shock me. Now to our next question, which is a little bit more science-based. It's, if a black hole absorbs everything, even light, how can they be spotted?
Ooh. So we're actually spotting things around black holes. So yeah, black holes can take in anything, but that's only if it crosses its event horizon. And the event horizon is very much based upon the mass of the black hole itself. So I'd like to give people an example of, say, my body. I am about 53 kilograms last I checked. If I just suddenly right now turned into a black hole, everything around me would be fine because my event horizon would be about the size of an electron. You would have to try to fall into my gravitational potential. I mean, that being said, call a physicist because I don't know how a human would turn into a black hole. But yeah, similarly, if suddenly the sun turned into a black hole, we would not be sucked in, actually, because it's the event horizon is much smaller than you would think it is. The event horizon is about the size of a college campus if the sun was just suddenly turned into a black hole without losing any mass. Now, we would die, but not because we'd be sucked in, because we don't have any light or heat, but our orbit would remain unchanged. So that's actually how we detect black holes. There's a black hole in the center of our galaxy that was discovered by Andrea Ghez, who was given a Nobel Prize for this. She and her research team actually tracked a bunch of stars going around this supermassive black hole in the center. So by measuring the orbits of stars around this supermassive black hole, they could measure its mass, and that's actually how they measured the black hole. Similarly, if you're a fan of Rush, I mean, this is Toronto, so everybody is. There's the song Cygnus X1. Cygnus X1 is actually one of the first discovered black holes, and they discovered it because it has something called an accretion disk. So it's so just because something is around a black hole doesn't mean it gets sucked in. So the Cygnus X1 has it's absorbing the light, the material off of a companion star, and that material is also moving so fast, sort of like the center of a galaxy cluster, so fast it glows in the X-ray. And this is actually how people detect it. So they don't detect the black holes per se, but they detect things around them. So hopefully that answers the question.
Yeah, I think that was a really great answer. And I liked how you compared to, like, if the sun turned into a black hole, we'd still orbit. And that's, because the mass is the thing that's really important in that scenario.
Mm-hmm. Yeah, so you have to get pretty close to get sucked in.
Yeah. Okay, so another question from the audience is, what Lovecraft story would you say would be the best one to read first?
Let's see. If you want just like any story, if you can find a version of Rats in the Walls where he doesn't use the racial slur, it's a great story. It is a fantastic story. It is so creepy. It's not scientific, but it's a great story. If you want something more scientific, let's see. The Whisperer in Darkness is very fun. The Color Out of Space is a very quick read. I actually listened to it over on YouTube. I found somebody reading it on YouTube. Honestly, you could get through it tonight if you wanted to listen to it, and then watch the Nick Cage movie.
Yeah, I guess it's also nice when there's a movie and then you can read and then watch and compare them.
Yeah.
Okay, so we're at time, but we started a little bit late. There's 2 more questions, so we'll get to both of them.
Sounds good.
Okay, so second last questions. Do you believe that the essential difference between like our universe and Lovecraft's is the existence of malignant intelligence?
I haven't seen any evidence of malignant intelligence other than from other humans myself. I would need more evidence to see any sort of malignant intelligence. And the thing about Lovecraft's malignant intelligence is that they actually don't care about humans. It's not that they hate humans. It's just they see like beings like Cthulhu and his friends. It's more that they see us like ants. We don't matter to them. So if they kill a few humans, they think about it like if humans kicked over an anthill. I mean, someone like me, I'm pretty soft-hearted. I'd feel sad. But these gods, we're just so underneath them. We don't have the brain power they do. We don't understand what they do. We're almost like bacteria to them. So it's not even malignant. In both cases, actually, of our universe and Lovecraft's universe, the universe is neutral. Well, I mean, I guess that there's no evidence that the universe is neutral, but I'm going to assume so until I see more evidence one way or the other.
Thanks for that answer. And our last question is, I heard about this theoretical telescope called Focal. It uses the sun's gravity, the sun as a gravity lens to view planets from the nearest star with high resolution. How feasible is this concept?
Oh my, I actually have no idea. I'm not an exoplanet researcher, but that's pretty clever. It would really have to be placed quite perfectly, I think, in order for that to work. However, I know that this has actually been used in a different context. I'm sure that this would actually work, but you would need to talk to somebody in exoplanet research or exoplanet discovery. But this is gravitational lensing is actually used in a method called gravitational microlensing, which a few of my exoplanet friends have told me about. Basically, what happens is a star might pass in front of something and gravitationally lens another star with a planet around it, and that could cause a change in its luminosity as it passes in front. It seems a little bit far-fetched, but people have detected planets this way. So it's definitely not far out there. I don't see why the sun wouldn't do that. Gravitational lensing magnifies the light from objects behind the star. I don't see why the sun couldn't do that. We just have to get kind of lucky, I imagine.
Yeah, it sounds like a cool concept. I haven't heard of that proposed telescope before, but yeah, it sounds interesting.
Yeah, I need to look that up. That sounds very fascinating.
And yeah, so yeah, that was our final question, but there is a comment from one of the listeners, Steve Huddick, and they said that they would like you to know that you are the most awesome person that they've ever heard speak.
Oh, that's so nice. I would love to get more talks on this stuff. I'm also hoping eventually to start a research project of some sort and how to utilize science fiction and science to more effectively teach science or more effectively communicate science to people, because I think it's actually kind of more effective. People who read a lot of Lovecraft, they actually understand some of the more some astronomical concepts, some cosmological concepts that can take some people a while to understand. So it might be a good way of communicating.
Yeah, I definitely agree. It's like, yeah, a different way to look at something, and it's also interesting. So it's not, just sitting there reading a textbook, reading how other people understood a topic. Like, it's really cool to be able to see things from all these different ways.
Yeah, not everybody wants to work out all the math equations to figure it out. Maybe they just want to be given the answer or think about it in a different way. Different people think different ways, and there are other ways to say look at it. So why not explore those other ways to examine these ideas?
Yeah, exactly. And I would like to thank you one more time. And I'm sure everybody is clapping from home. I can clap here. Thank you so much for that amazing talk. And I'd also like to thank all of our volunteers that helped make this happen, all the way from organizing the event to all the demos that we're about to go to. And I'd also like to thank our sponsors that help run these events. So that would be the Department of Astronomy and Astrophysics at the University of Toronto, the Dunlap Institute, and CETA. So now we are at the end of our talk portion, but you can visit our astronomy activities and demos at astrotours.ovis.in, and these will take place until 10 p.m. EST. The different activities are listed on the screen. We also have our feedback form, which is bit.ly/astrotours. You can just answer the first part, which is, scaling how much you liked things, like to what extent. But if you click to give more detailed feedback at the end of the form and go to the second page, you can also leave different astronomy topics that you want to hear talks on, and it can influence which talks we have in the future for AstroTours. So definitely fill that out. It'll help us out a lot and make sure that these events can be as best as possible. So yeah, thank you all for tuning in, and I hope to see you all at our Ovis space at astrotours.ovis.in. Thanks.
Bye, everyone.